Welcome. Dude, I tend to shout a bit, so like put your hands over your ears and let me know if I'm too loud. I'm Paul Badham. I'm here today to talk about Azure Functions, serverless computing with Azure Functions. I am curious, like this is supposed to be an intro talk. Do many of you know, have you used Azure Functions before? Yeah, okay, cool. So there's a few out there, but definitely some people who haven't, so good. So I'm an engineering manager on the Azure Functions team. I've been working on cloud stuff for Microsoft for about 5 years now. Prior to doing functions, I was doing mobile services, mobile apps, mobile stuff. And if we go back even further, I was working on WebSockets for .NET. So generally, I like to start with what is this serverless? Does this word make sense? What's it mean? Why is it interesting? I think the easiest way to answer this question is just in the context of the changes that we've seen in our industry over the last 10 years, basically the way the cloud is shaken things up and the different versions of it. So starting with pre-cloud, back in the good old days, we would buy servers, right? You would buy servers and you would have to install them somewhere. You'd have to pay somebody to manage them, make sure the operating system had the latest patches and so on. And this world was changed dramatically with the introduction of the cloud. And I would consider IaaS, infrastructure as a service, to be the kind of lowest level of abstraction that the cloud has given us. I'm not buying physical machines anymore. I'm renting virtual machines. I'm still managing those virtual machines, much like I used to do. It's just I have way more flexibility. If I need a whole bunch of machines tomorrow, I can make that happen because I'm on the cloud. So I don't think for application developers a whole lot changed with infrastructure as a service. The way you built your applications was pretty much the same. So then what happened next? What was the next level of abstraction? That's platform as a service. I think Azure App Service, Azure Websites is a pretty good example of platform as a service. You write a Node.js app, an ASP.NET app, you publish it to websites, and you have to configure it and think about how many VMs you need to run the app on, right? Is this an app that's memory hungry? Do I need to put it on some large VMs? A bunch of smalls will be good enough, that type of thinking. But you don't do much more thinking than that in terms of the machines that your application is running on when you're on PaaS. You can't remote desktop into the machine that's running your Azure website. You don't get that much access. So then you're definitely not doing, worrying about operating system updates and that type of thing at that point. So then the question is how can we get even more abstract if we're just following this progression? And I think that's what serverless is the answer to. What if we can get to the point where our cloud applications are mostly just bits of code reacting to events? And I'm not really thinking very much about the servers that this code is running on. So serverless is not, there are no servers, that would be kind of dumb. There's an abstraction, or you're abstracted away from the servers. I think that's the best answer. And so if you're going to be thinking about servers less, then the platform is going to have to be doing more for you, right? So you're talking about event-driven scale. If I've provided the platform with the code that I need to run, and I've said it needs to run for these events, if I'm getting a lot of these events, my code needs to be running on multiple machines in order to keep up with the workload. So then, if I'm not thinking about servers very much anymore, then my billing's got to change, right? I'm not going to be thinking about I'm paying for X VMs of this size for Y days. So what's the ideal? The ideal is you just pay for what is being used. If your code is running, you pay. If your code is allocating a bunch of memory, you pay. But if your code is not running, then ideally you don't pay, right? And so these properties of serverless here, they just translate directly into benefits. If I'm more abstracted from the servers, there's less to manage. If the platform can scale my code for me, then I don't spend as much time thinking about scale. I still need to make sure I build my application the right way so that the platform can scale it for me. There is still like some important things that I have to be aware of there, but I'm going to be thinking about scale less. And lastly, if I'm only paying for what gets used, then suddenly I have a lot more flexibility. If I have some ideas about some infrastructure, some automation, something that I want to stand up, I don't have to spend any time worrying about, is it going to justify its existence on the machines that I'm running it on? Did I have to set up some additional machines to run that automation or that infrastructure? Instead, it's just, I'll write it, I'll put it out there. If it gets used, if it's running, then I'll pay for it. If it's not used, then I won't pay for it, and I didn't lose a whole lot. So Azure Functions is Microsoft's offering in the serverless space. It's about writing code that responds to events. And you can write that code in C#, in F#, in JavaScript using Node.js. Those are the generally available languages we have, and then there's a bunch more languages that are in preview. PowerShell is a popular one, for example. It has all the properties we were just talking about. It is event-driven. It's going to scale based on the workload you're throwing at it. And we care about doing things like making sure that you can very easily make HTTP endpoints, for example, with functions. This is a thing that should be super, super simple to do. One thing I forgot to put on this slide that I think is cool is that Azure Functions is open source. The runtime that runs your code when it's running on the platform, it's on GitHub, so you should go check it out. I forgot to hit next for the animation. Okay, cool. So what's the programming model look like? You don't need to be able to read this code. The point is that it should look fairly familiar. It's a method. It's got a bunch of code in it that has some parameters. These parameters are going to be your triggers and your inputs. I picked a HTTP request handler here. So the input is the request that was the HTTP request that was made. There's going to be outputs. In this case, we were just returning an HTTP response. This is a super simple one. You can have functions that have multiple outputs, in which case you might be taking advantage of, say, out parameters in like C# code so that you can have a function that has multiple outputs. You take this code and you'll take sort of multiple functions and you piece them together into function apps. The function app is the unit of deployment. It's where your configuration goes. So if you have some database connection strings or something like that, you're going to put those in the function app, and the code in your functions will be able to access that config. Pretty simple stuff. So let me switch, and we'll do some demos of what it's like to play with functions. It's switched over. Now, when your code is not running, you don't pay for it. So sometimes opening this guy the very first time is a little slow. Oh. Really? I have no network? Come on. I had network before. Looks like the demo gods were just screwing with me a little bit. Come on. All right, cool. So, you can make a new function app in a couple of minutes, but I didn't want to waste your time. So I just made a blank one here before we started. And I'm going to just start with something simple. We'll just do HTTP. So we have a set of templates here for a bunch of different languages, a bunch of different scenarios. I'm just going to say, hey, make me an HTTP function. And it's a template, so it comes with some code sort of to help you get started. This one is just sort of showing you how to work with the request body or work with query parameters. It's given us a URL, so now that we have a function, we should be able to invoke it. So I'll just paste that URL. It's asking me for a name, and it's doing it in XML. It's doing that because we support content negotiation in functions, and Chrome asks for XML, still in this day and age. Let's say the name is Ignite. I'm sorry, that needs to be an ampersand. And it says hello Ignite. Okay, great. So I have a function. If I switch back and hit my logs here, you can see that we have streaming logs for your function. And this works very well with the online editing experience that we're providing you here. So we'll just say log info and say, hey, the name is the name that was just passed, and don't forget the semicolon, and we'll save. And if we look at these logs, we'll see that, hey, we saw that the file changed, a compilation occurred, and so now if I go ahead and run it again, we should see, hey, my name is Ignite in my output here. Okay, so that's fine. And if I don't want to be switching over to another tab, we have a UI for just running right here. So I can say run. This time it said, hey, the name is Azure. Why did the name change, this name parameter here? It changed because there's a UI with which we let you provide test parameters for functions. So you can see here, by default, this template says, hey, when you call this function from within the portal here, pass the name as Azure. And you can see it responded with a hello Azure back. Okay, so that was really simple stuff. Let's do something else. We can do timers. So, cron jobs is a really common one, right? You need to be able to run some job on some sort of regular schedule. By default, this template works, I think it makes me a function that runs every 5 minutes. So let's change that. I can do that in the integrate tab here. So you can see I have a trigger for my function, and the trigger has some config, and the schedule here is a cron expression saying every 5 minutes. I'll change that to every 5 seconds and save. And switch back to the develop tab, and if I did it right, we should see my function executing every 5 seconds. And once more. Okay, cool. So let's do something useful with this function. All it's doing is outputting logs right now. I'll go back to the integrate tab and I'll add an output. You can see we have a bunch of different options here. We're really focused on making it very easy for you to glue different systems together, different bits together with functions. And so we have options here for you to say, hey, this function should be outputting to event hubs, to service bus, to table storage. I'm just going to pick an Azure queue. I'm just going to keep it simple. It then asks me, hey, what parameters, like I basically asked me for a couple of parameters. What's the storage account that this queue lives in? And we can start there. It says Azure Web Jobs Dashboard. The reason it says that is because functions is based on Azure Web Jobs, which some of you might be familiar with. Web Jobs comes with a dashboard that uses a storage account. And so when you create a function, we make a storage account for you. And really what this is just saying is just use that default storage account. Rather than, I could go ahead and say new here, and it'll show me a pop-up and let me pick a storage account, but I'm just going to not worry about that. The queue name that I'm writing to is outqueue. Fine, we'll leave that as the default. And then here, this parameter name here is, this is important because you're going to need to be able to write to your outputs from your code. They need to have like parameter names. So I'm going to copy this, and I'm going to save and switch back to my code. And I'm going to say, hey, output a string with the same, make a parameter that's an out parameter with the same name as that queue output that we set up. So I'm going to then just say, hey, output queue item equals date time now, and save. And that queue did not exist, but the function's runtime will create it for me. And so if everything's working right, I should just be able to switch over and refresh my list of queues. And hey, I have an out queue, and I have messages, appearing on that queue. Awesome. Okay, so what do we want to do next? The obvious thing to do is to write some code that's going to consume these messages. I want to switch away from the portal for a second and open up Visual Studio to talk a little bit about some of the tooling we have in preview right now. So I'm going to say new project, and under the cloud category, you can see I have Azure Functions. So if you don't have this appearing, just search for Azure Functions Visual Studio, and you should find the tooling, no problem. So we'll go ahead and hit OK. And I'm going to add a function. And again, C#, sticking with C# for this session today. Queue trigger. The queue name was outqueue. Here, this tooling is still a bit rough. As I said, it's in preview. We still have a lot of work to do here. Ideally, this would be giving you some type of picker. Right now, it's just asking for, the name of the connection string, the name of the setting that has the connection string in it. So I'll just provide the same value that we had before. I'll hit create. And before we look at what it made, I need to go to this app settings file and update this now so I don't forget later. So this is your local config. This is, you're going to have, app settings in the cloud when you're running your function in the cloud. But I'm going to show you running the function locally, so I need the equivalent of local configuration. So I'm going to just use the same storage account. So I'm just going to grab this connection string, and I'm just going to paste it in both of these bits here and save. Okay, so now that I've done that, let's take a look at what the template made me when I said give me a queue trigger. This is super simple. It's just a function that takes a string, which is the contents of the queue message. Now, one of the cool things about functions is that you can just change this. Like there's basically a bunch of different options that we support. So you could be like, actually, I want the queue message as a stream. So you could just say stream, and we would give it to you as a stream. I'm going to leave it a string. I don't need to do anything here. And where's the equivalent of the config? Because we had the integrate tab in the portal. That's this function JSON file. So you can see here that it's just a simple JSON file that says, hey, this function, it's triggered based on this queue. And here's the name of the queue and so on. This JSON file, it lives when you're working in the portal as well. You just don't see it by default. If I go back to the portal and go to the integrate tab and hit this advanced editor, you can see here that actually what we were doing in the integrate tab is just basically working with this JSON file behind the scenes. So I don't need to change this file. The other thing that it made for me is a project JSON. I could easily add NuGet packages here and have it restore those NuGet packages for me. This will probably have to change eventually because Microsoft has announced that it's moving away from project JSON. But this is right now is how you specify your NuGet dependencies for a function. Okay, so let's run it. If I didn't forget anything, it should boot up and pick up all the queue messages that my timer's been making in the background while I've been chatting. There it goes. And then now it should just update once every 5 seconds based on the timer. So one thing I want to point out here is that this is not just like a local emulator. I'm able to run my functions locally against cloud resources just fine. And it's really handy because I can, of course, just use breakpoints now that I'm running locally. So here, my breakpoint's been hit. I can go ahead and resume. It'll get hit again, so on. So this experience is obviously oriented around addressing some feedback we got with the very initial launch of functions, which was about, hey, you're really only giving me a thing to do in the portal. Visual Studio is my tool. Why can't I write my functions in Visual Studio? Okay, so that's enough demos for the moment. I'm going to switch back. That was 2015. The tools there will be a version of the tooling available fairly soon after the 2017 release, I think. But right now, this is just you go and search for Azure Functions Visual Studio. You'll get the tools, you install them into VS 2015, and away you go. Yeah, they're available right now. They've been available for, I think, maybe 2 or 3 months, a bit of a while. So hopefully you've just seen you can develop in the cloud for Azure Functions or locally. We have a pretty decent portal that lets you write code, quickly iterate, you get your logs, you get your output, easily connect to other Azure services. Once you need something more powerful, you can switch to doing local development. I showed you using Visual Studio. We do have an experience in VS Code. The way to think about it right now is that if you're writing your functions in C#, then you should stick with Visual Studio. If you're writing your functions in JavaScript, then you're going to want to look at using VS Code. We have a local debugging experience for JavaScript in VS Code. One thing I didn't show is that C# functions in Visual Studio, you can debug them remotely as well. So this uses the same remote debugging feature of Azure App Service, of Azure websites. So you can tell Visual Studio, hey, attach to my function that's in the cloud and set breakpoints and remotely debug, which is pretty cool. The other thing I want to call out is that if you're starting to get to the point where the apps you're building on functions are starting to get a little bit more complicated, you need to do more code sharing between them. It's certainly easier today to do that working with Visual Studio. You can make class libraries and set them up to be shared within your function apps, sort of easier from Visual Studio than anywhere else. So how are people using Azure Functions? It surprises me every day, some of the ways that people use functions, but I wanted to go through some common patterns to maybe help get you thinking about ways that functions might make your life easier. We talked about timers already, some sort of nightly database cleanup job or something like that. Functions is a great use. Reacting to file uploads into blob storage. So you might have some sort of daily job that is uploading a CSV to blob storage, and that CSV has a bunch of data that's relevant to your organization, and you're using Power BI, and you're like, what's the simplest way for me to get this data into Power BI? A blob trigger in Azure Functions, grab your favorite CSV, NuGet package of choice, and grab the data and send it to Power BI, and away you go. Stream processing. This is a fairly obvious one. Event-driven architectures are pretty well designed. They work very well for stream processing. You might have a stream of messages coming into your event hubs or your IoT hubs, and you're processing that stream with some combination of stream analytics and functions. Towards the end, assuming I have time, I will have a quick look at doing a decent scale event hub stream processing scenario on functions, so we'll get to that towards the end. Serverless web applications. Web apps these days are becoming more and more rich on the client, right? We're using these libraries that are very rich, but of course that these web applications, they still need to interact with server APIs. This example here was just, hey, I have a web page, there's a user that's logged in, I need to show some data based on that user's profile. Functions is certainly a convenient way to do that. Bots are popular at the moment, and if you try Azure Bot Service, which is pretty new, I think that was sort of announced around October, November last year. What it'll actually do when you go into Azure and say, hey, give me a bot service, is it will also make you an Azure function. And the reason it does that is because we were working with them and we found that functions was one of the most convenient ways for you to answer the question of where do I put my business logic that my bot needs to interact with. So the template for a bot service sets up a function for you so you can go ahead and put your logic there. So when the guy says to the bot, give me a pizza, you would write your code for interacting with an ordering API within a function. Background processing, so you have a mobile app, and that mobile app is capturing photos or some type of images. Those are getting uploaded to storage, and you need thumbnails generated. Well, then that's an easy example that works very well in functions, and you'll see that in just a moment. And this one, DevOps automation, this one is important to me because, well, I guess my team does it. We have, for example, functions that are set up to validate PRs when people send us or update PRs for the Azure Functions code. So we use the GitHub webhooks to trigger our functions, run our validation code, and then if the PR passes, we then kick off a build. So I just wanted to look at what it's like to do a couple of these scenarios very quickly. And switch over again, go back to the portal. And we'll say, give me a GitHub webhook. So there is generic webhook support in functions. Don't necessarily need to don't be fooled by the fact that there's a template specific for GitHub. You could set up a Slack webhook or a bunch of other webhooks, no problem. It's just that GitHub is generally one of the very first things that if you point a developer at functions and talk about webhooks, they're like, I would love to integrate with GitHub. That's something that makes a lot of sense to me. So go ahead and make this GitHub function. By default, this template here, it's oriented around processing issue comments. You can see here it's grabbing some body of a comment on the request body that came from GitHub. So I'm going to grab the URL for this function, and I'm going to go to this repo I have here for playing with webhooks. And I'm going to paste my function URL in, and I'm going to say, please send me JSON. And I'm going to grab this secret here and paste that in, and say, I would like issue comments. Okay, let me then go to an issue in this repo and say testing 1, 2, 3. And my function should run. It did run, that's great. You're going to get sick of me adding logging statements. Let's just say what the GitHub comment was. Again, save, another comment. And there we go, another comment, great. So that's how easy we make it for you to set up code that runs in response to GitHub events. This example here was doing comment issues, but really all you're going to need to do is, for whatever webhook you want within GitHub, go and look at the request body it sends and figure out how to grab the data, and you'd be just changing this piece of code, and then you just do your logic, whatever you need to do. Let's do image resizing. So if I go to C#, grab this image resize template. This is asking for a bunch more parameters. This one is based around blob storage image resizing. So it's going to say, hey, I have a blob storage trigger. This function will run when files are uploaded into this container. And I want to capture the name of the file, and I want to use that in my output. I want my output to point to another container, but I want to use the same file name. So you can put these curly brackets around the bits of the data coming in so that you can reuse that data elsewhere. So I'm just going to leave all of this as is and just go ahead and create this. And if we expand the logs, we'll see that we're doing a NuGet restore for you. This template involved using a NuGet package. We can see that if we say view files and go to project.json, you can see we have a reference to image resizer here. If I go back to the function, we're using image resizer and we're getting some streams. So the first parameter here is the stream that came from the blob trigger. And then we have a couple more parameters here which are actually our outputs. Because streams are mutable reference types, we can just write to those streams, and they have the same names as the outputs that the template configured. So we can just write to those streams and it'll write them to blob storage. One of the things that I want to point out that I really love about functions is the fact that this code here doesn't talk about blob storage at all. The fact that this is doing image resizing on Azure Blob Storage is captured through the configuration and not through the code. If we wanted to change this function to do image resizing of images appearing in Dropbox, we could just do that through the configuration and leave the code pretty much exactly as is. So let's try it out. I'm going to grab some pictures of our keynote speakers, and I'm going to drop them into the right location. Refresh. Oh, I need to make, was it samples images? Sample images. Okay, and we'll grab this container and drop some images in and refresh our list of blob containers. And so now we have a small container, that has some 200 KB versions of these images and a medium container that has 400K, 500K-ish versions of these images. And that's it for this demo. Like, there's no other sort of magic behind the scenes. It's just the combination of blob triggers and blob outputs and using a really convenient NuGet library. Okay. So we've sort of covered some of the, what could you use functions for? Generally, the next sort of questions that people have are about some of the more sort of mundane practical matters. What's it like to deploy functions? What's the pricing if I'm not paying for servers and so on? So for deployment, you can deploy to any of the 18 regions around the globe that functions is available now. So we already have a very global footprint. I'd mentioned before, the function app is the unit of deployment. You put multiple functions into an app, and that's what you deploy. And the deployment works pretty much like app service deployment. If you've done Azure websites deployment, that type of thing, it's pretty much the same way. You can automate the creation of functions just using ARM templates like you would pretty much any other Azure resource. You can set up continuous deployment. This is one that I've used a fair bit. I was doing some performance testing, and so I wanted 5 different copies of the same function app that all had the same code in them, but I wanted to be able to run different load across those 5 different function apps. So I set up a GitHub repo. I put the code for my function app into that repo, and I made an ARM template for the function app, and then I ran that ARM template 5 times. I ended up with 5 function apps. Each time I go and commit to the code, it just does continuous integration, grabs the latest code, and updates. So that was really convenient. And you can deploy locally from Visual Studio. I didn't show it when I had VS open, but you can just right-click on that function app and say publish, and then you would just publish like you would publish a normal Azure website. So there's 2 different plans, 2 different SKUs for Azure Functions. There's the consumption plan, and you should think of this as the serverless plan. You pay for what you use. It's measured in terms of execution time and in memory, and the platform is responsible for scale. You can also run Azure Functions on traditional app service plans. So in this case, you're going to be paying for some number of VMs of a given size. That plan could be a basic, standard, or premium plan, usual app service pricing. And you're responsible for your scale if you go this way. You can still use something like autoscale. So you could say, hey, when my CPU is at 90%, add another instance for me. But the system is not going to be dynamically scaling really quickly. App service plans is much more suited for sort of more fixed workloads where there isn't as much variation. And there's some other reasons why you might choose to use functions on an app service plan and not the consumption plan. One reason would be if you have a really memory-heavy workload, we have some limits on the consumption plan. It's around 1.5 gigabytes. So if you have a workload that's going to load several gigabytes of data into memory to finish something, you'll probably write your functions and deploy them into a normal app service plan. The other reason you might do it, if you need to write functions that would interact with some on-premise resources, you can use virtual networks, get those networks joined to your premise network, and then you could start writing functions that interact with those resources, such as a SQL database that's not publicly accessible, that's only on your network. So how does the scaling work if you are in the consumption plan? It's pretty simple. We're monitoring the incoming events or traffic in the case of HTTP, and we're also monitoring how much resources are being used by your application. A good example of this is if your function app is a bit memory hungry, say it's running around 1 gigabyte of memory on average, we don't want to be putting that particular function app on small VMs that have less than a gigabyte of memory. If we did that, a whole bunch of paging would happen. You'd get worse performance. So it's a combination of 2, of looking at the events that are coming in and also resource utilization. And then the way you should think about the scale out when the system is scaling to meet the demands of your workload, you should think of it as horizontal scaling. It's basically about adding additional instances of your function app running on additional VMs. The pricing, there's 2 meters when you're in the consumption plan. There is how many executions occurred And then there is gigabyte seconds. Gigabyte seconds is the multiplication of the duration of your execution and your memory usage. And we do some tricks where we'll be sampling the memory usage regularly, so that if the amount of memory if your function ran for several minutes and the amount of memory it used changed dramatically, we wouldn't charge you for the max for the whole duration. There is a free grant. So you get 1 million free executions per month for a given subscription, and 400,000 free gigabyte seconds. So it's like a fraction of a cent per GB sec and about 25 cents per 1 million executions. So let's just do some super quick math to make it more concrete. Say you have like an app that's doing 10 million HTTP requests a month. It takes on average 250 milliseconds to execute those requests, and you're using about half a gig of memory on average. This is like a non-trivial workload, right? Hello World would be a lot less than 250 milliseconds and this much memory. So this is kind of like something a bit more realistic. If you just multiply it out, 10 million requests times 0.25 seconds and half a gigabyte, it ends up being 1.25 million GB secs. So then if we subtract the free grant, we'll end up with it being basically $17 in gigabyte seconds and $2 for execution. So you were doing 10 million requests a month for just under $20 in this case, for some sort of reasonable workload, something that wasn't 100% trivial. Okay, so this is where I sort of start getting away from this really like super simple level 100 stuff, because my team all the time, we end up interacting with customers that are using functions, and we see some pretty common mistakes. And so I have a stage, and so I want to get on my soapbox and talk about these mistakes. And so the first one is just high-level stuff. Your functions should really only do one thing when you write them. If you have a complex processing pipeline, break that pipeline into a bunch of different functions. Have those functions chained together through something like queues. But try to write each individual function so that it's only really doing one thing. And if you do that, then my second item here will kind of come for free. If you're only doing one thing in your function, then it should finish pretty quickly. It is important to make sure that your functions are not running too long when you're in the consumption plan, because there is a 5-minute upper limit on the execution time. People come back to us with very legitimate scenarios where they need longer than 5 minutes. A really, really slow FTP upload is a good example of that. So we are looking to see about whether or not we can lift this limit. But for most scenarios, 5 minutes should be more than enough, and you're just not breaking your functions up enough if you're running into it. The last one is very important. You should realize that your functions can be called with the same data multiple times. This might happen because of just some error, like an error in your code, so your function did not complete successfully, or some type of networking blip. Whatever it is, your functions need to be idempotent so that if they are called with the same data, if they are retried, they don't end up like doing a double write to some other system. If you're going to write some code that's inserting a record into a database, and you're going to put that in your function, you should probably guard that insert with a check to see if the record was already written or something like that. Just write them to allow for retries. Going down to the next level of detail, just a couple of basic coding things. This one, avoid going synchronous in async code. This applies across the board for .NET code, but I do see it a lot. So my example here is a function that is been written using async. It's receiving a blob, we're grabbing a CSV reader, we're getting the rows, and then we're calling some async method, but for some reason we are blocking on that async method by saying .result. You could do the same thing by saying .wait on a task, for example. Or you could be doing something similar by interacting with some other API that is just a blocking API. Whatever it is, it's going to cause you some problems. If you're in a position where you have to block your code and you can't write your async function all asynchronously, you might just want to look at switching it back to being written as a synchronous function. Mixing the two just ends up impacting performance, impacting throughput. It's just not good. You can easily end up having deadlocks. My example here is, because this is a contrived example, we just await the function, and that's it. That's all we had to do here. My next one, avoiding unbounded concurrency. By unbounded concurrency, what I mean is you wrote some code that could spin up n tasks, and n is determined by something else, such as in this case, we realized that, hey, we can process all the rows in this CSV in parallel, so I will just spin up a task for every row. You test this code with a CSV with 10 lines in it, and it works fine. You run this code with a CSV that has 10,000 lines, and it does not. You have multiple problems here. You're trying to do too much work at once, and in particular, it can cause you issues in functions because, as I was saying before, you don't necessarily always have a massive amount of memory to play with. 1.5 gigabytes is towards the upper limit. If your work is going to involve grabbing some more data, allocating more, then you might find that running a whole bunch of these in parallel within this single function execution hits your memory limits. So what do we want to do about this? This is not a one-liner to fix necessarily. You can split your work across multiple functions. I've already been talking about that. This particular example, you could grab 20 rows at a time from the CSV and then write those rows to a queue message. And if you did that, you would get actual good parallelism, because the system would see that you just outputted a bunch of queue messages, and it would scale up and run your code on multiple instances to process those queue messages. You'd get better parallelism that way. You had a question? I don't mind. Go ahead.
Can functions call off functions?
Not directly. The way we tell people to do it today is by using queues. It comes up a lot. So we have been talking about whether or not we could have one function call another function in your code, and that we would do the queuing sort of behind the scenes. Like, you definitely want to do it in terms of you want some sort of durable pass of control from the one function to another. So we don't want to have people just like call it directly. But I do think we could make it so that you basically call it directly in your code, and we do magic behind the scenes. And it is something we have talked about and will continue to consider. Yeah, logic apps would give you a way to do it. You can split work into batches. For this particular example, you could have just said, hey, I'll process 20 rows, I'll wait for those to finish, then I'll process the next 20. I wanted to do a shout out for TPL Dataflow, because this is a library that I love and I feel like it does not get enough attention. What does that look like? This is a code snippet from my last sort of demo, my Event Hubs demo, where what I'm doing is I have a number of load jobs to write. You can see there's an add async call there, and I'm putting that add async call in an action block, and then I hook up a buffer block behind the action block. I set a max degree of parallelism on the action block, and then I pump all my data into the buffer block. And what will happen is I'll pump 10,000 bits of data into this buffer block. 32 will start executing, and then as soon as one finishes executing, it'll grab the next one. So this is not like batches where you do 32, wait for them all to finish and do the next 32. This is consistent concurrency. And this works very well. It does require a few more lines of code to write, but I would definitely recommend, when you're writing functions and you think you have to do some amount of concurrency within a single function execution, consider using TPL Dataflow. So last set of best practices. Yes, the platform is capable of dynamically scaling for you. That does not give you a free pass to not do end-to-end perf testing. In the end, how well your app performs is going to be a function of how you wrote it. If you are making one of various different mistakes, some of the ones that I talked about, we'll be unable we'll hit limits in terms of how far we can scale you. Azure Functions is a real-world system. It's not magic pixie dust. It does have limits. The memory limit that I already mentioned was the example that I was citing here. And so while we're on the topic of memory a little bit, be aware that the functions in your function app share memory. So that means state can be shared across your functions. So if you have a bunch of different functions that are interacting with the same database, you might want to try to make sure that you set up a single database connection pool. And that might involve using like a static or some sort of singleton within your function. And you can use pound load in CSX to have one function load code from another file. So you can use something like that to make sure that you've got some decent state sharing across your functions. Your memory usage is averaged over all the functions that are running in that function app. And so all this means is if you have a function app that is maybe doing some really memory intensive stuff and some very lightweight stuff, you might find it becomes cheaper if you actually split those up into two function apps. That's all I was getting at here. Okay, so I'm going to do another demo. This one I wanted to do something a little bit different. I have to re-log in. I wanted to take a look at a function running at some decent scale. So I have an example that I've been playing with, which is an event hubs example. So it's basically an IoT scenario. Let's start with the code. I have a couple of projects here. I have a data processor. This function app is the one that is actually processing the load. And I have a load generator. If I'm going to show a function running at a decent scale, I need to actually generate a decent amount of load. And I was like, hey, why not use functions for this? That'll be fun. I have also a class library here, which has just got some basic data types. I'm reusing this class library by, this is kind of a bit of a hack. We need to make this better, but basically I have a build step that is copying my class library into my Azure functions. We recognize that you shouldn't have to do this, that you should be able to do like add reference. That's really what this is. And so that's something that will get addressed in time. But for now, this works fine for me. So I have this models class, the models library that's being used by both projects. Let's start with the load generator. I have two functions here. I have a timer, and this timer is, this is the code that we were looking at before with TPL Dataflow, is outputting a whole bunch of load jobs. I think I have it, the way it's running right now, it's doing 10,000 every 10 seconds, about 1,000 a second. And I want this basically, the timer, to spit out these load jobs, and then I have another function that's picking them up. And the reason I'm doing that, the reason why I didn't just write one function and try to put all the load generation in this one function, is that the system can't scale it. It's like invisible to the system if you're trying to do a massive amount of work within a single function execution. The way the system can see that it needs to scale your application up is because you're writing a bunch of messages to an event hub or to a queue or something like that. So in this case, my timer outputs these load jobs to an event hub, and then my load generator picks them up and makes some fake sensor readings. In this example here, we have basically some weather sensors and some seismic sensors. And so my load job here says, oh, you wanted a batch of a given size. I will make a bunch of those sensor readings, and I'll go stick them into an event data here. And that event data here is an output parameter that's been configured to write to event hubs. So does that make sense? Like in general, you're going to often want to think about, hey, I'm trying to do one thing. I'm trying to generate load, but I want this load to be at decent scale, so I need multiple copies of it running in parallel. So I have to output to something, and then have another function pick that up, and then the system will see that it needs to scale up. Let's switch over to the data processor. I have my splitter function here. And so you can see it's receiving a sensor event. And it's doing this, it's called a splitter because it's going, oh, is this a weather reading or a piece of seismic data? I need to send it to the appropriate place. And you can see here, you might not have encountered, if you haven't used Azure Functions before or web jobs, you would not have encountered the iasync collector type because it's something that we added. This is a way for you to have a function either A, get around the fact that you can't use output parameters in async functions in C#. So places where I was using like an output parameter before, compiler will say, no, you can't use output parameters. So I need some sort of type here that I can pump values to that acts like an output parameter. And the other property that it has is that it lets you output multiple values to a single output. So this code here is doing some enrichment of the data. We're adding like some additional metadata and stuff to the messages, and then sending them on their way. There's like 2 more event hubs, one for weather data, one for seismic data. Finally, I have my, my weather data processor here that is basically right now, it's not doing much. It's just sort of collecting some telemetry about how long it took for messages to work their way through the system. So it's going to consume those messages, and I'm sending that telemetry to App Insights. So right now, Azure Functions, you can easily use it with App Insights, but it requires you to set it up manually. So you go and grab your App Insights key, you stick it in your configuration settings, and then you can go ahead and use the App Insights SDK to send data there from your function. We are actively working on doing more built-in integration. So you would basically just check like a checkbox and say, yes, please send me basic execution information for my functions to App Insights. And then you would grab the SDK if you wanted to send more information to App Insights. Okay, so that was probably good enough in terms of a review of sort of the code for this scenario. If I switch back to the portal here, basically I have a dashboard that I set up that has got, so showing me the traffic on the event hubs. So my weather event hub here is sitting around 1 million messages outgoing. And I can actually get a much better view of exactly what's going on by opening the live stream. You can access this live stream from the monitoring section of the portal. It's faster for me to hit this link directly, except it broke. Come on. Okay, cool. So it doesn't look like it's streaming. Okay, we're getting there. It was just a bit slow to start. So what we're able to view here is like real-time executions of a given, I've picked a given function. This is my weather data processor here. And we were talking about how my load generation was happening in like batches, like I have a timer run, and it outputs a bunch of load jobs, and then it sort of sits there for 10 seconds and it runs again. So these spikes you're seeing are basically the spikes of load that's coming in the system. So this function right now is sort of varying between around 3,000 to 10,000 messages a second. You can see there we just did 12,000 in about a second. So we can collect some more data because I did say that I was pumping some stuff to App Insights, right? So if I go into App Insights here, I have a query where I was trying to track whether or not the system is keeping up. Did I throw too much data at it? There is, and we can talk about what is too much and why there might be too much in this case. But what I was looking for to see is my average end-to-end latency varying dramatically. What I don't want to see is it just like hockey sticking or growing up linearly, because that means my system is simply not keeping up. Right now, the end-to-end latency is varying a bit, but this is over the last hour. It has not gone up dramatically, so the system is keeping up. If you have spent any time with App Insights, you'll know that it actually collects a whole bunch of data for you for free. And one of the cool things that's kind of a neat trick, I think, is one of the things it does when it collects metrics is it collects the cloud role instance that it sent the data from. So this query I wrote here is going to give us an idea of how many VMs our function is actually running on right now. And so it's running on around 30, 33, 35. This number makes a lot of sense if you, A, know event hubs, and B, know that I configured my event hub to have 32 partitions. The way our processor for Azure Functions uses the event hubs processor, event processor host, And the event processor host will naturally load balance your Event Hub processing such that you get to the point where there's one machine processing one partition. So if I have 32 partitions, then it would make sense that the system has given me about 32 VMs. And that's what my workload is running on here. So I was talking before about how I was checking to see, am I throwing too much load at this? If I threw enough load, that meant that a single machine can't keep up with a given partition, that might be at the point where I'm starting to max out. And then you say, well, what do I do then? The answer would be, you can call the Event Hub team and ask them for more partitions. They don't let you select it through the portal, but you can do it. Okay, so that's pretty much my at-scale demo. Let's go back to the slides. I would highly encourage you, if you've not tried functions yet, give it a go. You don't even need to have an Azure subscription to do it. If you go to functions.azure, I think most people at Ignite have a subscription, but anyway, if you go to functions.azure.com, you can kick the tires with functions without even having an Azure subscription. I have got this slide for you. I think you must have seen this 20 times by now. And there's the Spark After Dark drone giveaway. With that, we can go to questions. So, yeah. Right. So the question was, we were talking about like the blob resizing example, and you could use logic apps to call functions. And can you do like async patterns when you have logic apps call functions? You can do it, but you would do it yourself. So you would write your function to be an HTTP trigger, and you're going to have to figure out how you want to do your work tracking, right? Like if you're going to make a function that returns a 202 and it gives somebody a URL to say, hey, poll this URL and to find out when this job is done, then you're going to need to write another function that can actually receive that URL and tell you if the job is done. So you might do that by having some table in your system somewhere where you write your async jobs, right? And then so the code that you have that's receiving the HTTP call to find out if the job is done is looking up that table. But there's nothing built in to the system, I think, is probably the short answer to your question. You would just implement that pattern yourself with HTTP functions. Did that make sense? Yeah. Okay. There was a question up here. Where they're different, yep. That makes sense. So the question is about Azure Web Jobs and Azure Functions and their similarity and what the plans are. So it is absolutely the case that Azure Functions builds heavily on top of Azure Web Jobs. If you go and look at our GitHub repo for the functions runtime, you'll see it references all the Web Jobs SDKs and stuff. So it's all very visible there. I think that for us, in a lot of cases, we see functions as superseding web jobs. That might not be the official line, but certainly when we talk about it a lot within our team, a lot of the cases that people were using web jobs today, like in the past, it's super easy to do those scenarios in functions, right? And in functions, because we do give you the option of running those functions on a dedicated app service plan, it's not like you're missing a whole lot by doing those scenarios that you traditionally did in web jobs in functions. Because if you don't want to buy into the pay for what you use, you're just like, I'm paying for this one VM already, and I just want to run my functions there. That's fine. You go make a function app, you put it on the same app service plan, that has got that one VM, and away you go. So that said, because the Web Jobs SDK is a dependency for us, it's still getting lots of love. If you actually went and looked at the GitHub repo for the Web Jobs SDK, you'd see a bunch of activity over the last year or so. And we will continue to do releases of the Web Jobs SDK, but certainly there's more effort being spent on functions, the short answer. Right, the ability to run continuously. So are you talking about just you would write a single function that, because there is the ability, you can make a function app and put it on a plan that has always on, and then your functions are always running. But if you're talking about just a single function that is running continuously, and I think that's what you can do in the Web Jobs SDK, right? You can basically make a single job and just say run continuously. You're right. I think that you would basically be faking that in functions today. Exactly. A time one runs every 5 seconds would fake that. But there are some other examples. Web Jobs has got a singleton configuration where you can say that this particular web job, there should only ever be one copy of it running. That's something that we've received feedback on. I know we have a GitHub issue for this. People are saying, I need the same thing in functions. So there are still some gaps. Right. Yeah. So there are still gaps. It's not like functions 100% replaces every web job scenario, but I think the vast majority it does. But as I said, we're still using it. We'll keep investing in it and keep releasing the bits and so on. Any other questions? Yep, I think you were first, yeah.
I have a question around, say, Swagger API. As you build lots of these web endpoints, you then have to, in the API apps that's generated for you.
Yes.
In the function app, especially you want to consume that in Logic App or
Yep.
Flow.
Yep.
You kind of need a Swagger API.
Yes.
What's that story?
Right. Yeah. Right now, it's awkward is the short answer, and my hope is that that's going to change very soon. There are a number of integration scenarios that people are trying to do with functions. Like you mentioned, Logic Apps is one. Another one is Power Apps. Power Apps is super heavily Swagger driven. And so we would like to get to the point where you have an experience where you can go into your HTTP functions and pretty much just add some additional metadata. You can be like, this HTTP function returns this particular result type. This is the JSON schema of that result type. It supports these type of operations. If you could go in there and you could do all of that, then we could pretty much just generate the Swagger for you at that point. Between the extra metadata you provide and the metadata we already have, we could pretty much make a Swagger document.
That sounds easier in, say, C# but harder with Logic.
So it would work for both because you wouldn't be doing it through code. You can use the JSON schema format to specify your request body and your return types, and it would work just as well for both. If we manage to get a solution out there, it won't be specifically for C#. It'll be pretty much for any language that you're using HTTP functions for.
So is this something on the issues that we could follow?
Yeah. I'm going to be at the speaker lounge later, so I think I could probably, if you come find me, I could probably find the issue so you can follow it and track the progress. There was another question. Yes.
Yeah, I've seen people use functions to serve up HTML content, small-scale websites.
Not yet, though. It hasn't stopped people from trying, because it's kind of the dream, right? Because you're trying to get rid of all these server pieces. Why not get rid of the thing that's serving your HTML? it is something that we've gotten requests for, but it's not sitting at the top of our priorities, I guess, is the short answer. What I would love to see is one thing that does hold the scenario back a bit is you can't, if Azure Storage would let you do custom certs, then you could serve a bunch of your static content direct out of Azure Storage, and that would be really cool. I think that if they get that working, then that would address some of this scenario. I think otherwise, as we get to more of the easy stuff being done, we might come back to looking at HTML. It's just a little bit more tricky from just the way it's going to interact with our billing model. We don't know exactly. It's just a little bit different. It might end up being super expensive. Like you can have cached HTML and have it be super cheap to return, but we have a minimum execution time of like 100 milliseconds. So it wouldn't be useful for us to go ahead and add this capability if you then used it and you were like, my bill's a joke. This is like way more expensive than just a small VM. So for us to do it, it has to be thought through that billing area too. Up the back, yeah. Right. So the question is, what can you do for your authentication and authorization around HTTP functions in particular? There is some very basic stuff built in today. You might have noticed the URL that I copied right at the very beginning for the HTTP trigger. It had a code in it. And so that is a thing that we're doing where by default, when you make HTTP functions, we generate a key and we secure the access to that function with a key. But that's very basic. That's API sort of security. It's not user authentication and authorization. You can turn on app service authentication and authorization. Yeah, but you can, sorry, so to be clear, either way, regardless of your SKU, you can turn on app service authentication. The problem is that the way app service authentication works is it will like block all requests by default or something like that unless you're authenticated, right? That causes us some problems with our portal because our portal, when you open it, it makes a bunch of requests to the function app. So we have a bunch of work to do to make it so that experience is really seamless. But the way I see it, the way it will work is that you will be able to turn on app service authentication, and you should be able to basically sort of configure it and say, hey, these are the HTTP triggers in my function, so these are the things that you should be standing in front of and requiring a user for. And then what we'll have to do as well is make it so that once the user is logged in and he accesses your function, we need to make sure that you have the right APIs you need to get the user context, like to make sure the user principal is populated correctly, that type of thing. App service authentication is already doing most of that, so I think it'd be just mostly about smoothing the rough edges. The bigger challenge is that you can turn on app service authentication today, but it makes the portal not work. So obviously, the fact that it kind of just breaks the portal means that we don't have that 100% baked yet. That's the realistic answer. Any other? We still have a few minutes, yeah. Yep. Yep. Oh, yeah. You don't need to do that. So. Right, so the question is if you're doing ARM deployments, how can you avoid, I think I have seen examples of people doing this where they've set up an ARM template for their function app, but what they did was inlined the code for their function app into the ARM template. You have a couple of better options. One of them is that your ARM template can have an MS deploy step. So you can use the local VS tooling and do a build and say package and give me like basically a local MS deploy package, web deploy package. And then you could take that package and stick it up on blob storage or something like that. And then your ARM template could have an MS deploy task that references that package. Okay, so that's one way to do it. Yeah, I mean, I don't know exactly the thing you're referring to for API apps, but we do have examples. We have some ARM templates that show using MS Deploy, or I can definitely get those examples to people. So again, if you can catch me after, I could sit down and sort of show you the exact way to do it. There is another way. I guess the other common way of avoiding inlining your code is to use one of the continuous integration options, where you put your code in VSTS or GitHub, and you can configure the ARM template to say, when it comes to the content of this function app, deploy it from this repo. And that can be super convenient because it doesn't require you to build and re-upload these web deploy packages every time. You can just have a GitHub repo that has the current state of what you want deployed, and you just have ARM templates that reference it. All right. I think we're done. Thanks so much. I'm going to be in the speaker lounge, as I said, so I want to talk shop with people, especially because this was an intro talk. So if you have more advanced topics you want to talk about, I'm always keen. Thanks very much.